All right, lesson 4 here is we're getting into displacement with acceleration. So how far does something move when it's accelerating? We talked about what its velocity would be when accelerating. This is how far it goes, how much it actually moves when it's accelerating. So here's kind of the intro. When an object is accelerating, this is the basic idea. Velocity changes. Okay, means it goes up or down. Position, well, it actually changes constantly, changes linearly. Okay, in other words, it keeps going up constantly, 5, 10, 15, 20, whatever. Or it goes down constantly, 20, 15, 10. The velocity is changing constantly or consistently, linearly. Position is not linear, okay? Position changes quadratically, meaning, okay, talking curves up like that if we graph position versus time, or maybe it curves down, okay, not linear, it's changing, the slope is constantly changing. Okay, so it's actually going to be a quadratic equation. So the equation for position when accelerating, this is a big one. X of t, okay, position x. Let's say x0, okay. I was using an I earlier, but I'm going to change to a 0 just because that's more common. So that's the starting position plus VOT. Your initial velocity, this VO is your initial velocity. Instead of saying VI, I'm going to use VO just because it's more commonly used. I kind of used VI by accident. Okay, plus 1/2 AT squared. There's the quadratic part. Okay, so if you notice, it kind of looks like a quadratic. It's like x squared, then there's an x, and then this is just a constant. So it's kind of like that ax squared plus bx plus c. It's just kind of written the other way around. Okay, so here's an example. Example 1. A car starts from rest. And rolls down an incline with acceleration equaling 2.0 meters per second squared. Okay, for 3 seconds, actually 3.0 seconds. We want to know what's the displacement? How far did it go? Okay, let's just use that formula. Find the position at a certain time. x0 plus v0t plus 1/2 at squared. Actually, let's draw it out first, because on these it's really a key to draw it out. I'll draw it out over here. Then we can get all our variables in place. Okay, so x0 is actually 0, meaning it starts at position 0. Doesn't say anything about it starting at a different position. v0 is actually 0. That's the starting from rest. Okay. Down here, the time we want to figure out is 3 seconds. And what else do we know? I think that's about it, right? A, it tells us, is 3.0. I would just put that somewhere along there because that's happening the whole time. Okay. What is x of t? That's the position down here. Okay. Okay, so 0 plus 0. Okay, that's kind of silly. But if you want to plug it in, it would be that, right? This is the part that's going to have an effect, right? 1/2 times 3.0 meters per second squared times t is 3 seconds squared. Okay, squeeze that all in there. All right, so it's basically 0 plus 0. That's gone. We just got to look here. It's 1/2 times 3.0 meters per second squared times 3 squared is 9.0 seconds squared. Notice I got squared too. Look at your units here. Second squared is going to cancel out with second squared. I'm just going to end up with meters, which is good. So we got a half times 3 times 9 is what? 1.5 times 9 I think is 13.5. Okay, so the final position down here, we're really finding x of 3. The position at 3 seconds is 13.5 meters. Okay, let's try one more. The key is do draw that picture out first, and then that will help you figure out where everything goes. Okay, we're going to push a car up an incline. Okay, so the car is pushed up an incline with initial speed or initial velocity 4.0 meters per second. The car accelerates at negative 2.0 meters per second squared. All right, what's the position at 1 second? 1.0 seconds. All right, it's a very similar problem, but it's now we're actually pushing it uphill here, and we're trying to figure out where is it after 1 second. Okay, so let's fill in stuff. X0, 0 meters. Okay, that's usually the case, unless it happens to be starting at a different position. V0 is this initial velocity here. That's actually the 4. Okay, what else? They're telling us A is negative 2 meters per second squared. That I'll just put in the middle. X of t is what we're trying to find here. Position up here. V up here, we actually don't know either, right? But it actually didn't ask us for that, so we're probably not worried about that. Never mind. Okay, let's look at our equation. X0 plus V0t plus 1/2 AT squared. 0 again, meters. Okay, now we do have a V0 here, so this is going to be 4 meters per second here. Times t, okay, the t is what we're plugging in, okay? So the t is actually still, that's what I needed to put up here. T is 4. 1, t is 1. Okay, so it's like a function. Whatever t I'm plugging in, I put it in here and here. Okay, plus 1/2. Negative 2 is the acceleration, meter per second squared, and then times 1.0 seconds, squeeze it in here, squared. Okay, t squared. All right, this is 0. This is 4 meters, right? Meters per second, seconds. The seconds cancel. So we're left with 4 meters plus 1/2 negative 2.0 meters per second squared. And then this comes out to 1.0 seconds squared. It's kind of tedious to keep track of all your units, but it is important that you do that so you can see how it comes out. Okay, so we got 4 meters, and then we got 1/2 times negative 2 times 1 is actually just negative 1. And look at your units, meters per second squared, second squared. The second squared cancel, we're just left with meters. So it simplifies down to 4 meters minus 1 meter, so we're talking 3 meters. Okay, so that would be x of 1, okay, is 3 meters. If you keep plugging in, you'd notice that eventually it comes to a stop. In other words, its position will keep getting bigger and bigger as you plug in a bigger time. but eventually it actually is going to start getting smaller and smaller, and it's going to come back because it's a quadratic. And you think about a quadratic, they go up and they come down. So the cool thing is that, you know, this function will get bigger, but then it will get smaller, and it will tell you the exact position of that cart at any time. Think of it as an algebra function. Plug in a time, and this will tell you the position of the car at that particular time. Okay, I think that should be enough for you guys to do your homework. Good luck.